All right, guys, let's go ahead and get this one done. Let's see, this is the arithmetic combination. You read through number one. Write a function, f of x, to represent the price after the 80% markup. All right, so you're going to start with f of x equals, right, and here's your original price. And then if you mark it up by 80%, then it's the original price multiplied by 0.8, right? So that's the function of f of x. Now you can also do this. You can factor a x out. So if you think about it, it's going to look like this. X parentheses, and you factor x out of this term, you get 1 plus, and you factor x out of this term, it's 0.8. So in actuality, your new function will be x times 1.08, because you can actually now add those together, which is 1.08. Oops, not 0.8, 1.8. That was my mistake. So so x times 1.8 or 1.8x. So either one is fine. I like this because this is nice and compact, but this other one is also, the original one that we had is also fine. Okay, the second one, write a function g of x to represent the price after a 25% markdown. All right, so you're going to start with g of x. You take your original price, or whatever price that it is, and you're going to go ahead and mark it down by 25%. So it's going to be subtraction of 0.25 and then of the original price, which is x. Again, you can do the same thing. Okay, factor the x out, and then be x on the outside, and that'd be 1 minus 0.25. Right? And if you think about money, $1 minus 25 cents is 75 cents. So it'll be x times 0.75. Right? So if they mark it down by 25%, you're actually paying 75% of the original price. So you can also write down 0.75x. Okay, and that's the better function, but you can also use the original one of x minus 0.25x. Okay, either one is fine. Use a composition function to find the price of an item after both price adjustments that originally cost the boutique $150. All right, so if we read through this, the original, it says a boutique price merchandise by adding 80% to its cost and then later decreasing it by 25%. So that 80% is first. So when we rewrite this, the 80% is going to be first, so we're going to use f of x as the innermost function. Okay. And then when we do the 25%, that's g of x, which is the outer function. So this should actually be g of f of x. Okay, and we want to find out what that is. Now, and again, it says that they want you to find out the price adjustments of both after the original cost of $150. So instead of the x, we're going to utilize $150. Okay. So first we're going to do $150. When you put it in here, $150 marked up 1.8 or 180 times. Okay, because it's 80% marked up from its original value. So so it's going to be, let's see, so we're going to do red function. So it'll be 1.8 times 150. Okay, so we're going to get that value. And after that, we're going to go ahead and multiply that. So then we're going to go ahead and put in this value here by 0.75. Okay, so that's how it works. So let me pull up my calculator. Calculator. Okay, so that's going to be 0.75 times 1.8 times 150. Okay, that gets you $202.50. So that's going to be 202. So this is going to come out to be 202.50. Okay. Now let's do that one at a time to see if that works. The same. Right. So you get $150. Right. That's the original price. Right, and they're going to mark it up by 80%. So you're going to go ahead and add $150. So that's the original price, and you're going to mark it up by 50% of, or 80% of 150. So times it by 0.8. Okay, and that gets you $270. And then you're going to take that $270 and you're going to go ahead and subtract or mark it down by 25%. Right, so it's $270, and you're going to subtract $270 times 0.25. Okay, and that gets you 202.50. Same answer. Okay, or you can utilize any of these other functions that we wrote down. Okay. Okay, does the order in which adjustments are applied make a difference? Okay. In this case, if you notice what we did at the end, we went and did 75 cents times $1.80 times 150. And you notice that it's all just multiplication. And multiplication is commutative, meaning that it does not matter the order in which you multiply, because it's all just multiplication. For example, you can do 3 times 4, and that's 12, or you can do 4 times 3, that's also going to be 12. So it doesn't matter the order that you multiply it in. So in this case, to answer this question, it is there is no it doesn't matter the order adjustments, right? I'll let you write that in. I'll just write no, since multiplication is commutative. Okay, meaning that the order doesn't matter how you multiply. Okay, that was number 1, surprisingly. Number 2, let's see, f of x, which is this one, added to g of x. So we're just adding them together and putting like terms together. So if I'm looking at them and just adding like terms, let's see, I'm going to start with x squared. So that's just x squared and nothing else. So I'm going to have 2x squared, and the x squared, we have x, so 4x and nothing else. So it'd be plus 4x. And then after that, we're going to go ahead and add -1 and +3, and that's going to make +2. Okay, second one, f of x minus g of x. Notice that it's minus g of x right here. It's a minus g of x, which means that g of x is going to be the opposite. So this is going to end up being -2x squared and -3. Okay, and we're going to go ahead and do the same thing. We're just going to go ahead and combine them and add like terms. So we're going to start with the biggest exponent. So it's going to start with -2x squared. And then we're going to go ahead and do 4x. So plus 4x. And then we're going to go ahead and combine the constants, -1 and -3, which is going to make -4. Okay. f of x times g of x. This one I'm going to go ahead and use an area model just to kind of simplify things a little bit. Okay, so because we're multiplying it, and again, multiplication doesn't matter the order, so I'm just going to go ahead and write it in any order I want. Okay, 4x minus 1 and 2x squared plus 3. This is going to make 8x to the third. This will make minus 2x squared. This will make positive 12x, and this will make negative 3. Right, so I'm just going to go ahead and just write it down accordingly to what I have, and nothing really combines because all the x's are different powers. So I'm just going to write it as is. So it's going to equal 8x to the third minus 2x squared plus 12x minus 3. Okay, and I'm going to go ahead and erase this area model. If you need it, just rewind back. Okay, f of x divided by g of x. Okay, so if I do this one, and actually I'm going to clear this out. Right, so if you need to, rewind back because it's gone now. Right, so f of x is on top, which is 4x minus 1, and g of x is on the bottom, 2x squared minus plus 3. Right? And actually, I can't do anything with that. That's the best I got. Okay, this is g of x minus f of x, meaning f of x becomes opposite. So that's opposite, and this right here is a negative, so I'm just going to become opposite, which is a positive. And I'm going to start with my biggest term, which is 2x squared. So this is going to equal 2x squared. My next biggest term is negative 4x. And then I'm finally going to have positive 1 and positive 3, which is going to be positive 4. Okay, lastly we have g of x divided by f of x. G of x is 2x squared plus 3, and f of x is 4x minus 1. And again, you can't do anything with that. Okay. Let's see. Quite a bit already. Okay. So let's go ahead and get this done.